Well, howdy folks. So in this last video about the domain of functions, I want to go ahead and identify the implied domain of a number of functions that you've worked quite a bit with. So just as a reminder, if the domain is specified for a function, then you use that specified domain. That's what we said last time. If the domain is specified, that specification is the domain. More often than not, though, if the function's domain is not specified, if the domain of a function is not specified, then the domain is implied to be the largest set of real numbers for which the function is defined. And what we get into with these problems is the fact that there are a few problematic operations. The problematic operations are the following. Problematic. The first one is everyone's favorite problematic operation, division. And here the key is you cannot divide by 0. So if your function, the rule of assignment for your function has the operation of division on it, and the domain is not specified, then it's on you to ensure that you're never going to plug in a domain value. You're never including a number that would allow the situation where you'd have division by 0 attempting to occur. So you need to make sure that you're not going to divide by 0. So let's look at this problem right here. Here we have f of x is equal to 1 divided by x. Well, we ask ourselves, what problematic operations do we see in this expression? And the one that I see is that we are doing division in this, and we cannot divide by 0. So what I'm going to do is I'm going to take the denominator, which in this case is just x, and say that the denominator cannot equal 0. So now I'm ready to give the domain of f as, I'll do it in two ways, from minus infinity to 0, unioned with 0 to infinity. That shows that we exclude 0 from the domain, and I'll do the same in set builder notation. That's the set of elements, x, such that x can be any real number except that x cannot equal 0. Okay. So let's do the next problem together. So here I can see that we have a new polynomial function. This new function is named g, and I see again that I'm doing what problematic operation? As I'm examining this function, what operation am I doing that can get me into trouble? And the problematic operation that I see here is division. You cannot divide by 0. Well, I want to point out real quick that g of 0 is defined. If I were to plug 0 into this function, we get 1 divided by 0 minus 2, which just simplifies to be minus 1/2. Notice 0 is in the domain of this function, whereas 0 is not in the domain of the previous function. So you need to be a little careful when answering these questions. This information that I give you on the side here is what we need. Okay, so we need to make sure that we're not dividing by 0. So let's take the denominator, just like we did before. Now in the previous problem, the denominator was x, and that's almost so simple that it gets us into trouble. Here, the denominator is slightly more complicated, x minus 2, and we want to make sure that that does not equal 0. Well, if I solve this negative equation, if you will, if I go to solve this, this would say that x does not equal positive 2. So now I'm ready to give the domain of g as the interval from minus infinity to positive 2, to positive 2, unioned with 2 to infinity. And if I were to write that in set builder notation, that'd be the set of elements x, such that x is any real number, and x does not equal 2. Folks, do make sure that you're writing both forms in at least these early problems that I'm working through with you. So on this handout, please write both forms of the domain just to get comfortable with both ways of writing this. I'm going to minimize this slightly for the notes. Okay. So now let's go ahead and tackle C. C is going to involve some work. We can again see that this function, h of x, is built up of all of these operations. We've got squaring, we've got subtracting, we've got multiplying by 15, multiplying by 2, cubing, etc. But there's only one problematic operation in this expression here. What is it? Again, it's division. So we've got to make sure that we do not divide by 0. So we need to make sure that x cubed minus 2x squared minus 15x does not equal 0. On the left-hand side, I could factor this. First rule of factoring is to pull out the greatest common factor. So let me do that. That would give me x times x squared minus 2x minus 15 cannot equal 0. Then we'd have that if I continue to factor, this would factor as x minus 5 times the quantity x plus 3 cannot equal 0. So at long last, I arrive at the statement that x cannot equal 0, 5, nor negative 3. So here in this case, I'm not going to write out the domain in interval notation. It would take too long. I'll just do it in set builder notation. That's the set of elements x, such that x can be any real number, except that x cannot equal 0, 5, or negative 3. And there's the domain of this function c here. You see how difficult these problems can become. We may have to do some factoring to be able to identify the domain of the function. Okay, so for the next problematic operation that I want to look at, the next problematic operation I want to look at is radicals. Okay? Specifically, even indexed radicals. Now, I'm just being very careful with my vocabulary, folks. I'll explain that in a minute. Even indexed radicals says that we cannot take the nth root of a negative number. So if I have the nth root of x, if n is even, then x needs to be greater than or equal to 0 to take the appropriate radical. So that's a little bit heavy. That's a lot going on there. Let's specifically mention, you can only take the even root, or excuse me, you can only take a non-negative root of a, let me say that one more time. Specifically, you can only take square roots of non-negative numbers. Now careful, can you take the square root of 0? Yes, you can. The square root of 0 is 0. What you cannot do is discuss the square root of minus 4. This is not a real number. So currently in this class, we're just working with the real number system, and we cannot, in the real number system, discuss the square root of a negative number. Okay, so this is getting a little lengthy, but let's just see what we can do here, folks. In this problem here, we're being asked to state the domain. I didn't tell you what the domain of n of x is, so you're asking the question, what are all the numbers I'm allowed to plug in for x into this expression? Now, I believe that many of you are able to look at this and just identify the answer just from looking at it. That's good, but it's going to get you into trouble when you get to a problem over here. Where over here, I think you're going to have a harder time identifying the domain just from looking at it. So although I know you may be able to give the domain of this function right here, I need you to learn the method that I'm about to show you so that you can do this harder problem over here. Okay, so let's go ahead and tackle this. We just said that if we're taking a square root, we can only take the square roots of non-negative numbers. So the stuff inside the radical, let me write that down for you. Let's give some vocabulary here. We call this the radical. Okay. And the number right here is called the index. Okay. If no number, it's 2. So it's a square root. Okay. And then we call the stuff inside the square root sign, let me just put a letter there. We call this stuff inside the square root sign the radicand. Okay, so just being careful with our vocabulary here. So here I've got a square root. We can see that the index is 2 because nothing was written there, so it was implied to be 2. So this is a square root. And it's even, right? Our index here is even. We can only take the square root of non-negative numbers. So what do we need? We need x minus 4 to be non-negative. So we need x minus 4 to be greater than or equal to 0, which means we need x to be greater than or equal to 4, solving that inequality. Now careful, folks, because these are going to get a lot harder, and this gives you a little bit of an insight for where we're going with this. So yes, I know you might have been able to say, I can only take the square root of numbers 4 or larger based on looking at this expression, but it's this inequality that I want you to start thinking about. Okay, so if I were to give the domain of n here, there's two ways I could do it. I could do it in interval notation. That's a nice way to do it here. We could go 0 to infinity. Or I could say that the domain in set builder notation is the set of elements x, such that x is any real number, and x needs to be greater than or equal to 4. I have a typo there, folks. Let me correct it in just a second. Folks, this should have been a 4 here. That's a typo. That should have been a 4. I'll put the typo in a different color so you can see it there. So that should have been a 4 there. Okay, so I want to run through the next few questions. We're going to do them a little bit quicker now. Careful. Sometimes students get in the habit of just saying when is a function 0, and that's bad. We need to be really careful. I'd like to do letter F first here. The domain of this function, the domain of S, and I'm going to do it in set builder notation, is the set of numbers x such that x can be any real number except that x cannot equal -7, +4, or +5. Okay. I want to specifically point out what we said before. Whenever you're asked the domain, you should ask yourself, what problematic operations am I dealing with here? And in this case, the problematic operation that I see is the operation of division. And what do I have to be careful of? I have to be careful to not divide by 0. Notice that if x were -7, this factor in the denominator would be 0, meaning their product, the product of all three of these numbers, would be 0, and I would be ending up with a 0 in the denominator, which is the equivalent of trying to divide by 0. So we have to exclude -7. Same thing with 4, same thing with 5. Okay, well, let me ask then. Let me ask, is -3 in the domain of this function? Yes, it is. If you were to evaluate s of -3, you can evaluate that just fine. This first factor would evaluate to 0. This first factor would evaluate to -8. This factor in the denominator would evaluate to 4. This factor to -7, and this factor also to -8, but that just gives me the answer of 0. Is that a problem? No. There's nothing inherently wrong with the number 0. The problem is you cannot divide by the number 0. So what I'd like you to do is I'm going to have you pause the video, and I'd like you to answer letter E on your own. Go ahead and give the domain in either interval or set builder notation. But please, folks, it's especially important that you pause the video and actually try this so that you have a working guess. Okay, so for this problem, actually what you should have found was the domain of K is from -infinity to infinity. That's one way to write it. Or if you had written in set builder notation, the set of x, such that x could be any real number. That's what we should have found for the domain of this function. Now, before you erase anything, I just want to point something out. A lot of students think that we should exclude 0 and 5 and -3 from the domain of this function. That's where you can get into trouble. What problematic operation am I doing in this function? Let's go identify. Is it number 1 or number 2? It's actually neither of them. And in fact, if you were to expand this whole thing out, what you actually have is a polynomial. And the domain of a polynomial, unless otherwise restricted, is all real numbers. Okay, 2 more questions to go, and then I'll let you try it on your own. So here we've got a radical here, folks, and so that's the only problematic operation I see. And what do we say? We said the radicand needs to be greater than or equal to 0. So we need x to be greater than or equal to 0. That's good enough. There's the domain. So the domain of this function m here will be from 0 to infinity in interval notation, and let's also write it in set builder, the set of elements x, such that x is any real number. Oops, I'm sorry, and x is greater than 0. That's a mistake there, folks. Let me fix that. And x is greater than or equal to 0. Okay, so last question here, and this is really what I'm trying to get you to in this assignment, is to be able to find the domain of this function right here. And I've had students try to guess the answer, and I promise you, eventually I will give you a problem that's so hard you can't just guess the answer. You need a systematic way of working through it. Okay, well, let's give it a shot here. I only see one problematic operation in this expression. I see division, I don't see division, but I do see that I'm taking a square root of an expression here, and I've got to ensure that the radicand, that's what we call the stuff underneath the square root sign, that the radicand is greater than or equal to 0. So what do we need? So let me write that. We need 3 minus 5x to be greater than or equal to 0. I'm now going to solve this inequality. So I need minus 5x to be greater than or equal to -3. And then remember, when solving inequalities, different from solving equations, this is not an equal sign. If you multiply or divide by a negative number, we have to reverse the direction of the inequality. If you have any questions as to why that's so, if you've never wondered why that's so, or you've wondered and you haven't learned the answer, please come by and see me. I'd love to explain that. Okay? But anyway, to go ahead and isolate the variable x, I'm going to divide both sides of the equation by -5. If I do so, I get that x is less than or equal to -3 divided by -5, or that x is less than or equal to 3/5. So be very careful here, folks. Note right here the sign change in the inequality. Okay. So at long last, I think I'm ready to give the solution to this more difficult problem. And in this case, the domain of the function p in interval notation would go from -infinity to 3/5, including 3/5, because that says less than or equal to. Or if I were to do this in set builder notation, it would be the set of elements x, draw that such that bar, x can be any real number, and we need to add the restriction that x needs to be less than or equal to 3/5. So there we've given the answer in both interval notation and in set builder notation, practicing both of those. So folks, for the last part of this problem, I'm going to have you give the domain of each of these functions here. So we've got A, B, C, D here, E. So I'd like you to try all of those. I will include the solutions to some of them, but not all of them. So try them on your own. Then check the solutions. And then when you're done with that, make sure that you go and you work our MyLab Math pre-work for this section. I'll see you next time, folks. Thanks for your patience.